Dan Perry here with part 12 of our TCP/IP Basics, How to Subnet. In this video, we're going to begin talking about how we subnet a network and break it into those smaller pieces, how we do the calculations of those subnets. Now, we're going to work our examples with a Class C network. This is because it's very easy or much easier to work with a single octet for subnetting, and once you have the principles down, then working with a Class A or Class B network for subnetting is not that much more difficult. Real life, you're not going to use the Class C and subnet those as often as you would the A or B due to the fact that a Class C is already only 254 host machines on it. Now, when we subnet, using classful subnetting, the older technique, which is again the best way to learn, you have to borrow at least 2 bits from the host portion of the network when you subnet. In any case, classful or classless, you must leave at least 2 bits in the host portion. This means that at least 2 bits have to be part of the host. Up to 30 bits can be part of the network portion. Well, looking at a standard Class B subnet mask, yes, I know, I said we were going to talk about a Class C, and that's how we're going to do our examples. But just to illustrate, we normally have the first 2 octets, or the first 16 bits, as part of the network, and the last 16 bits as part of the host. In this case, we've borrowed 4 bits from the host portion, leaving 12 bits in the host. So after that, we now have 20 bits as part of our network, 12 bits in our host, and when you convert that third octet, which is the one that changed from binary to decimal, you get a 240, giving us a subnet mask of 255, 255, 240, 0. Classful subnettings, you do lose some of the networks that you have. The first and last network in a subnetted network are not usable. So we lose a number of IP addresses that way. Those first and last networks in this classful addressing, the first is for the network address. It contains the unsubnetted network address. The last contains the unsubnetted broadcast address, and for that reason we lose those 2 networks. This can be very inefficient, especially when we start looking at the Class C due to the number of IP addresses that we lose. Now, there are a lot of ways to calculate subnets. Most of the references, they have you calculate directly the number of usable subnets, taking into account losing that first and last, and the number of usable IP addresses that remain. Now, we've already said we lose the first and last network, so we always lose 2. The way we calculate the usable networks is we take the 2 and raise it to the power of the number of bits that we borrowed, and then subtract 2 from it. That subtracting 2 is for losing that first and last network. Now, to calculate the number of usable IP addresses, you take the number of bits remaining, the number of bits that are in the host portion, and you subtract 2 because the first IP address in any subnet or any network is the network address, and the last is the broadcast address. So the usable, when I say usable here, we're talking about machines can be assigned those IP addresses calculated. Now, I like to work a little differently. I like to calculate the total number of networks, total number of IP addresses, and then figure the usable numbers from that. And I find it easier to do that. I find when I build the spreadsheet that we're going to see in a future video, that it is easier to build that spreadsheet that way. And when you see it, I think it will make sense. Now, Next time we're going to actually begin looking at how we choose our subnets and actually do the subnetting.